name is Allison Fry, and I'm a master's student at SMAST. Today, I'd like to talk a little bit about some of the background and approaches we are using to study Atlantic cod in southern New England's offshore wind lease areas. So first off, I'd like to acknowledge the many great and diverse collaborators for this project. My advisors, Steve Cadron, Sophie Van Paris, Tim Rowell, Mark Baumritter, Greg DeSells, Micah Dean, Matt Knisa, Bill Hoffman, Alex Hansel, Chris McGuire, Susan Tuxbury, Doug Zemeckis, and Rebecca Van Hook. This project was primarily funded by the Bureau of Ocean Energy Management. So before we get into the acoustic telemetry, I'd like to share a little bit about cod and discuss some prior work, which really set the stage for the Southern New England Cod Project. So Atlantic cod are currently managed as two units within the US, the Georges Bank stock and the Gulf of Maine stock. Both stocks are well below target biomass levels due to high fishing pressure and population declines in the late 20th century. Despite management efforts and reductions in fishing pressure, both stocks have failed to rebuild, likely due to poor recruitment, overfishing, and climate effects. Some other notes about the species: they're winter and spring spawners, and they also vocalize during spawning, which makes them a candidate for passive acoustic monitoring. So many of my collaborators worked on a series of studies to characterize cod spawning of behavior and dynamics in Massachusetts Bay. They used an array of fixed acoustic telemetry receivers paired with a glider and continuous passive acoustic monitoring to result in high resolution data of fish movement and habitat use. Results from this work show interannual spawning site fidelity, meaning that cod are returning to the same location year after year to spawn. When they do so, they're forming dense aggregations with very specific spawning behavior. And due to the site fidelity and the nature of the spawning aggregations, these activities have been shown to be highly sensitive to human disturbance. So the methods used here with an array complemented by a glider and passive acoustic monitoring really served as a model for our current project in southern New England. In addition to the work done in Massachusetts Bay, there's been a recent effort to identify the stock structure of Atlantic cod in the US. The Atlantic cod stock structure working group has conducted an interdisciplinary review to characterize the biological population structure beyond that of the Georges Bank and Gulf of Maine management units. The report identified 5 distinct biological groups, including the Gulf of Maine and Cape Cod winter spawners, the Gulf of Maine spring spawners, southern New England, Georges Bank, and the eastern Gulf of Maine. This population structure is not currently reflected in the management units, and this could potentially be one of the reasons why we're not seeing the rebuilding of cod populations as expected. Many of the research recommendations from this report point to the southernmost group, southern New England, where there is still very little known about the biology and spawning dynamics for cod. Also happening in southern New England, the Bureau of Ocean Energy Management has designated lease areas where private corporations will be developing offshore wind farms. You can see the lease area shaded in a darker blue in the chart to the right here. The specific orange box outlines the South Fork work area, which overlaps with Cox Ledge. Cox Ledge is a historically documented cod spawning ground, which has also been designated as essential fish habitat for cod. Construction is planned to begin within the next few years in this area, and it remains poorly understood how or if species which utilize this habitat will be affected. So with that background knowledge, the recent identification of the southern New England cod population and the imminent development of offshore wind, we've developed 2 study objectives. First, to broaden our knowledge of southern New England cod biology and spawning dynamics, which will have important management and stock identification applications. And secondly, to collect baseline data of habitat use to address potential effects of offshore wind development. So to meet these study objectives, we are using a multidisciplinary approach over the course of 3 consecutive winter spawning seasons, starting in 2019-2020 and continuing at least until the winter of 2021-2022. We're collecting opportunistic fisheries-dependent biological samples to further define where and when cod are spawning on Cox Ledge and in surrounding areas. We're also using acoustic telemetry with a fixed array of 10 receivers plus an autonomous glider, which is deployed with an additional acoustic receiver, as well as a hydrophone for continuous passive acoustic monitoring. So here's a layout of our year 1 array. We have 10 non-overlapping fixed receiver stations denoted here with red circles and letters, and the glider track is outlined in purple. We were able to modify the array design slightly for year 2 based on the detection data from year 1. The glider track line was shifted slightly to better cover detection hotspots, and a few of the fixed locations were also moved. I should note the passive acoustic monitoring data from the glider is able to detect other sound-producing animals beyond just cod, like whales and other fish, which will be very important for characterizing the effects of wind development. But for the sake of this talk, I'll just be focusing on telemetry and cod detections from the glider. So since this is a telemetry conference, I'll get into our gear specifics a little bit. We have 10 BR2W Vemco 69 kilohertz receivers, plus 1 on the glider. We go out and download our data every 6 weeks or so. We faced a decent amount of year loss during year 1, and we suspect this to be from high vessel activity in the area, storm events, and a 4-month period where we couldn't go out due to COVID-19. We use a mooring system similar to the one depicted here. However, we have modified the surface gear from a high flyer to a more low profile, low drag buoy system, and we've seen a reduction in gear loss since that transition. So for the fun part, the tagging, we're using rod and reel methods on chartered vessels out of Point Judith, Rhode Island. Any fish over 50 centimeters we consider to likely be in spawning condition and large enough for the implementation of an acoustic transmitter. We cannulate if possible to confirm the spawning condition and then perform the surgical procedure. We try to keep the fish pretty happy with water on the gills while we insert the tag into the abdomen, and then we monitor the fish's health in a live well before releasing it. If a fish is below the 50 centimeter threshold, we just use a standard T-bar tag in the dorsal area and collect tag return call-in data if the fish is recaptured. So far, we have 38 acoustic tags deployed between November 2019 and July 2020. We hoped to release 100 tags during each spawning season, but the catch rates have been lower than we would like. And this past 2020-2021 winter spawning tagging season was interrupted by COVID-19. But we'll have one more winter of tagging next year, and hopefully we'll be able to get some of these tags out. So here's a preview of some of our year 1 results. The purple circles are the fixed receiver locations scaled by the number of COD detections. The blue triangles are detections from the receiver on the glider, and the yellow marks are detections of vocalizations from the passive acoustic monitoring. The glider was actually able to detect fish outside of the array and also pick up fish that weren't detected within the moored array at all, which really shows the benefit of the glider in increasing the spatial scope of the study. Preliminary analyses of year 1 and 2 data show spawning site fidelity, with some fish remaining within or returning to the array during the consecutive spawning seasons. And I would also like to note that our opportunistic biological sampling has shown evidence of ripe and spawning fish outside of our array, which suggests that cod are using surrounding habitats to spawn as well. I'd also like to briefly discuss the collaboration and data sharing with this project. We are working closely with the Inspired New England Aquarium Highly Migratory Species Array. Jeff Kneebone will be talking about this work right after me. But I would like to point out the proximity of our arrays. So you can see here, the COD receivers are shown with red triangles and the HMS array with blue circles. The collaboration here greatly supports both projects by significantly increasing the spatial coverage of the arrays. And we also share our tag and detection data as frequently as possible with the MATOS network. So we are pretty much right in the middle of our project right now after just finishing the second winter of tagging. We'll be tagging for a third year, hopefully increasing our sample size and moving forward with more formal data analyses. And just to wrap it up, I'd like to greatly acknowledge Captain Greg Mataronis out of Secaunet, Rhode Island, and his crew for their work in gear logistics and the receiver array download and maintenance. I'd also like to thank the charter vessel captains and crew out of Point Judith, who are very helpful on tagging trips, and the many SMAS students, faculty, MAS DMF employees, and other colleagues who have volunteered to come out tagging with us. So with that, I'd like to open it up for any questions or comments. Thank you.
Does anyone have a quick question for Allison? All right, up next, we're going to have Jeff Kneebone talking about highly migratory species monitoring in southern New England at the wind energy arrays.
Great, Kim. How you doing? Thanks. Are you seeing my full screen?
Yes, you're good to go.
Awesome. Thank you for having me. Hello, everyone. I just wanted to say I'm getting warnings that my internet connection is, of course, unstable, so I apologize in advance if I freeze. I have another computer teed up if I freeze completely, so Kim, I'll be watching your face. If you can leave your video on for me, that way if you freeze, I will start over, but I apologize. So thanks again. I'm Jeff Kneebone from the Anderson Cabot Center for Ocean Life at the New England Aquarium. As Ali said, with a great segue, we are looking at highly migratory species fish monitoring in the southern New England wind energy areas using telemetry. So it's a really nice fit with MATOS. And before I start, just like to acknowledge my partner in crime, Brian Gerbelis from Inspire Environmental, who's working with me on this project, and he and I have spent a lot of time planning the approach, the objectives, and actually doing some of the fun field work. So just quickly, this project started off fairly simple with a grant proposal and a pilot study that was funded through the Massachusetts Clean Energy Center with funding support from BOEM and Rhode Island DEM. And that was really just the project that got us going. But as you can see at the top here, it's really evolved in the past year to be quite complex. So right now we're talking about 4 different independently funded projects with 2 project teams, 6 different funders, 3 different offshore wind developers. The work is being conducted in 5 different wind energy lease areas, and we're trying to put it all together into one regional monitoring plan. So it's kind of a constantly evolving project and a really complex one, but we're really excited about where we are and where we're going. So I'll just try to give you a brief orientation to what I will talk about in the next 10 or 15 minutes. So I just talked about how we got our start with that Mass Clean Energy Center grant. Since then, we've branched off to get contracts and work directly with 3 offshore wind developers. So Ørsted, Equinor, and Mayflower. And below the black line, you can see, what groups are involved in the project. So from my end, I'm kind of serving as the link between all of these in terms of telemetry. But as I said before, Brian Gervelis and Inspire Environmental are very much a part of the process. And in the bottom, we're just hoping to use MATOS and hopefully other platforms like that have been talked about this morning to really amplify data sharing in this area. We're working with SMAST and ALI and the COD project already, but we're looking to try to go beyond that to branch into new species. So just quickly to orient you to this region, Ali did a nice job, but to go a little bit in more detail with the actual developers. So there's 4 developers, Vineyard Wind, Ørsted, Equinor, and Mayflower. You can piece them together in this chart. So Ørsted's kind of up here, Vineyard Wind, if you can see my cursor here and here, and then Equinor and Mayflower, just to kind of, this would be a roadmap for trying to link back to where we're actually doing the work, because it's easy for me thinking about this day in and day out to just spout out these names and expect everyone to know what I'm talking about. So if you get confused, hopefully you'll remember this map and put a place to a name. In terms of our project goals, it's a little different than like a hypothesis-driven or really traditional telemetry study like I'm used to doing. For offshore wind, there's a lot of interest in monitoring. So we want to know what the impacts of different offshore wind activities are on the species that naturally inhabit these areas. So what are they doing naturally? How are they affected by conditions in the region, environment, physical oceanography, things like that. And then we want to know how the actual construction of the turbines is going to impact the animals. And then after that, how is the operation of those turbines going to affect the animals? So you're really trying to link together 3 periods. And to do that, you need to establish a long-term monitoring system for the animals themselves. And that's what we're trying to do with passive acoustic telemetry. So for the short term now, since the lease sites have not yet been developed, we're in that baseline, our pre-construction phase. So our short-term goals for this project are just to collect basic information about the animals. So where are they, when are they, where they are, and how are they moving around this area? And we're doing that with telemetry arrays. And the other thing that we're really hoping to do is to try to continue to prove how acoustic telemetry.
Jeff, you froze.
So obviously offshore wind is happening in a lot of different areas. And we're not trying to reinvent the wheel. We're just trying to make it known that this is of great use. Kim, I see your face. Am I freezing?
You were frozen, but then you came back in. So I think you're good.
Okay. Should I repeat anything?
I think you're okay. It was only a few seconds.
Okay, so basically we're not trying to reinvent the wheel. We know that telemetry has been used in other areas for monitoring for other species. And all we're doing here is trying to extend it to HMS and into southern New England. So for our approach and objectives, for that initial Mass Clean Energy Center proposal, we really needed to keep it focused and kind of get our foot in the door. So we decided to focus our monitoring on the 3 most important recreational highly migratory species in southern New England. So in this region, for those who are not familiar, the recreational fishery is really bigger than the commercial fishery by a long shot for HMS. So through a survey work that I did with one of the developers, we've chose bluefin tuna, blue sharks, and shortfin makos as the 3 most important recreational species for the region. So we decided to start our tagging with them. And then in terms of where we were going to monitor, we wanted to just pick the areas within the lease areas that were most often used by recreational fishermen when targeting these species. And you can see all these different named locations here on this map and how they relate to where the actual lease areas are. So that's where we started. Our approach is kind of evolving as momentum is building behind telemetry as a regional monitoring for HMS. So now we're trying to go beyond those specific recreational fishing areas and monitor basically the entirety of lease areas. And we also wanted to branch out into new species. It's well known that bluefin, blue sharks, and shortfin mako are not the only 3 species that use this area. So we're trying to bring in more species to do more inclusive monitoring. And then, of course, in the context of MATOS and ATN and everything else, data sharing is really important for this region. We're collecting data on Atlantic cod, as well as a lot of other species that are migrating to this region or using this region. So there's a massive capability for data sharing and building other species models into the monitoring plan. So just quickly, in 2020, through that Mass Clean Energy Center funding, we had 15 acoustic receivers. This is the exact same map that Ali showed with the receiver locations in blue, focused again around the most popular recreational fishing areas. We deployed 29 tags, kind of split evenly between bluefin, blue sharks, and shortfin makos last year. And just to show a little bit of data, this is just where all the locations where the blue sharks were detected. So if you look at this chart, it's kind of confusing. So the green circles are where the blue sharks were tagged. And then the actual shark cartoon is on top of a receiver location where they were detected. You're smiling again.
You're good. I just like your
Okay.
cartoon sharks.
Oh, thank you. Sorry, I thought I froze. So yeah, blue sharks, nothing new here. We knew that they were pretty common and widespread to this area. And indeed, even tagging animals outside the lease, they came in and used the entire area. So just a tidbit of information there. For makos, same type of plot. Our tagging was over here. So we've tagged, I think, about 8 or 10 of them over in this area, and then a bunch of them kind of moved to the west into this, portion of the lease. So again, take home message, even though they are not in our array, they did move in at some point in time. And even more so for bluefin. So the bluefin last year kind of set up home down in this region. We tagged a bunch down here as well as a couple over here, and you can see they moved into the receiver array. So nothing really new. We know the animals are moving through this area constantly for feeding, for migration, but it's just really was nice to see that we can use telemetry and fixed position receivers to monitor a wide range of HMS. So where are we going in 2021? Well, if you go back to the beginning, I talked about how complex this project has become. Since those 15 receivers, which are here in red, I know they were in blue previously, but they're in red here, we've added a lot more. So the orange is what Ali just talked about, the Atlantic cod receivers that SMAST and Mass Division of Marine Fisheries are kind of maintaining. So we're building a nice array here. The purple is a couple of receivers that were funded by Ørsted, the developer, to kind of fill in some holes over here. And then the newest addition for 2021 is this area down here. So 2 developers, Equinor and Mayflower, have joined into the telemetry monitoring framework, and will be deploying a arrays of 10 receivers in each of their lease areas starting in about a month. So we'll have about 50 receivers going into this, all the lease areas in Southern New England in 2021. In terms of tags, we've got the 29 that we tagged last year. The battery lives are, I believe, 5 to 7 years, a mix of internal and external tags. So we hoping that those individuals are detectable. And we also have 81 more transmitters that we're going to be deploying in 2021. Again, a mix, mixing in some new species, white marlin, carcharodonid sharks, fresher sharks, which we have a pretty big project going on in addition to this. So it's hopefully we're going to get to mesh it all together into one nice big offshore telemetry array. And then just to end, I just wanted to give a brief update on what else the aquarium's got in store. We're really ramping up our receiver arrays in this region in 2021. So I already showed you the telemetry for the offshore wind monitoring. Up here, these white circles are our planned receiver array for Nantucket Sound, and that's really going to support projects on 3 species, sandbar sharks, sand tiger sharks, and some new tagging that a colleague, Dr. Kara Dodge at the Anderson Cabot Center at the aquarium is doing on leatherback sea turtles and loggerhead sea turtles, where they're trying to start tagging them with acoustic transmitters and getting into some more long-term monitoring. So that's all I had. I have a couple minutes for questions and happy to answer them, and thanks again.
Thanks, Jeff. Does anyone have any questions for Jeff or Allison? It looks like Dave does.
Yeah, thanks. This is for Jeff. A really nice presentation. And I guess all our striped bass are now going to go to this area instead of off Massachusetts, where all the previous density of receivers were. But you showed the arrays that we put out, and Mike Frisk and Dwayne colleagues did. There's design elements there that we all looked at, and we thought that off Delmarva was a migration corridor, so we set out a gradient style thing, and in other areas they thought they were more of a kind of hotspot, so they did concentrations of receivers. It seems that this is kind of a fortuitous affair. Is there any way to build design elements? I see a little bit in the outer receiver arrays. It's a uniform grid, which it's its own kind of hypothesis that you may want to talk about, but what is the hypothesis that you're testing with this kind of grid array? I think it merits some thought.
Yep, that's a great question, Dave. And there's a lot of different factors at play, and there's 2 different sides to this. You're right. So I'll start on the western side first, and we really needed a way to kind of, like I said, get our foot in the door and get momentum building around this. So we had to focus our efforts on those recreational fishing areas, and then we just had to try to cover them as best we can based on the resources we had. And I did some work on recreational fishing effort, and we kind of picked out where is the largest amount of fishing effort occurring, and that's where we put our receivers. So that's the one side. With the grid array, that's kind of preliminary. I think I put it down here in the right. I'm working with the developers to try to figure out what the correct layout is going to be. We want to try to coordinate between them because the leases are so close and it's 2 different companies. So it's kind of been a little bit of a challenge. And the other thing is we're really cognizant about interactions with commercial fishing vessels. So there's specific places that we have to avoid to reduce the risk of gear loss. So that doesn't really answer the hypothesis question, but it's I guess we're still kind of trying to flesh it all out, and I would be very interested in talking with you about your experiences if you have any insight.
Okay, it looks like Steve also has a question.
Hey, Jeff, great presentation. And thanks generally for your collaborative approach. You've been a great help to us, and I assume just as much a help to others. So my question is, It looks like the Vineyard Wind lease area is a kind of a big hole in this array. Are there plans to have deployments similar to what you have in Equinor and Mayflower in the Vineyard Wind lease area? And sorry if I missed that.
Nope. I hope. I've been in contact with Vineyard Wind for a while. I feel like I bother them a lot. I see this coming together as a really big regional monitoring platform, and there are conspicuous holes, and I'm working on trying to bring them on board. I don't think it'll happen in 2021, but I'm optimistic about 2022. And then that kind of feeds into Dave's question about, hypotheses and objectives. Like, I was really kind of hoping that we'd have everyone on board and we could meet and flesh things out early, and then I would build from there. But it's been a little bit of a struggle to get to where I hoped to be, would be with a normal telemetry project, where you have all the funding established up front and we're not trying to piece things together.
Well, if we can have the adaptive approach, I think that'll ultimately work. And I can try to help as well as to continue to work with Vineyard Wind to try to promote this. And I agree with you, is that the more we can coordinate these separate deployments, we will achieve kind of a design that would meet hypotheses. I mean, this could be, similar to a transect that's going across one of the ocean tracking networks. In fact, even broader. So yeah, thanks for that. And I'll continue to try to help for that.
Thanks, Steve.
Dave, did you have one more quick comment?
Yeah, I'm sorry to mean to hog it, but I'll put it down the link. But Jeff, I didn't know if you're part of the ROSA guidance discussions, but certainly that's what we're all talking about, is the regional monitoring approach. And we didn't spend a lot of time talking about telemetry, but I would advertise that to the group that for offshore wind, there is a regional monitoring guidance document that talks about this adaptive approach that Steve mentioned. And I'll go ahead and put that link down to the ROSA document. And Jeff, I assume you have that.
Yeah, let's connect via email, and I can update you on my activities in that arena. Thank you again.
Yeah, great conversation. If anyone has any more questions for Jeff or Allison, feel free to reach out to them. But we are going to move on to Caitlin McGargle. Sorry if I butchered your last name. Who's down in North Carolina working on southern flounder.
Can you hear me?
Yes, we can.
Can you see my screen?
Yes, you're good to go.
Thank you. Thanks, Kim, and thanks everyone for tuning in from your couches or offices or wherever you are. I am a research associate with East Carolina University. My name is Caitlin McGarrigle, pretty close there, Kim. And I'm just going to be talking about some early results that we've seen and some exciting data that we're collecting on a new project that we've been working on, looking at the offshore spawning grounds and migration corridors of southern flounder. So for those of you who aren't familiar with southern flounder, they are found along the East Coast from Virginia to Florida, and as well as in the Gulf of Mexico. And they're the most common of the 3 flounder species found in North Carolina. They support a very valuable finfish fishery here, both commercial and recreational fisheries, which have a combined estimated economic value of about 150 million per year. However, unfortunately, they're considered overfished in North Carolina and throughout the southeastern states, and we've seen declines in both spawning stock biomass and recruitment, despite best management efforts. There's a number of challenges to managing these fisheries. Most of the fishing interactions occur within the estuaries and sounds, and so we really don't have a lot of information about their oceanic part of their life history, because there's no fishery interactions with them out on the shelf. However, we do know that the adults leave the inshore areas in the fall, and this is largely driven by drops in temperature and precipitation. and that the larvae appear back in the sounds and estuaries in the late winter and spring. However, there's a lot that we don't know, especially about the oceanic part of their life history. We don't know where they're spawning. We don't know what's happening to these fish after they spawn, whether they return to the estuaries and maybe interacting with those fisheries, or whether they're remaining offshore, in which case they may provide some resilience to fishing pressure. There's also some conventional tagging evidence that a large number of fish migrate to the south. So it's important that we have this sort of data so that we can determine both the spatial scale of management, as well as appropriate protections for both spawning stock and habitat. So our project aims to answer these questions along several different pathways, but today I'm just going to focus on our first two objectives, which are to determine the timing and migration pathways of fish leaving the sounds, as well as track their offshore migration movements and locate potential spawning areas. So to do this, we've been collaborating with commercial fishermen to collect fish in our three primary tagging areas, which are the Albemarle Sound, the Pamlico Sound, and Core Sound. We've targeted the largest individuals we can get in the hopes that they will be making spawning migrations. And based on a subsample of these fish brought back to the lab, the vast majority of these are mature females. This year, we tagged 110 individuals, and the tags were evenly distributed among the three sounds. Transmitters were surgically implanted into the coelomic cavity, and I won't go into the details because most of you are familiar with tagging procedures. In addition, we also externally tagged these fish with a North Carolina Division of Marine Fisheries tail loop tag. And this is so if fish are recaptured later in the study by commercial or recreational fisheries, they can report this to DMF and we can still get some information about fish movements. In addition, we collected 30 to 60 fish from each site to do some otolith microchemistry and gonad histology, but I'm not going to go into details of that today. Our receiver array consists of an inshore array of 21 VR2W and TX receivers that are evenly distributed among the 7 major inlets in North Carolina. They're deployed either from the surface on U.S. Coast Guard navigational buoys or from the seafloor on independent moorings when necessary. We also have an offshore array of 20 acoustic release units that create sort of this acoustic curtain just south of Cape Lookout Shoals. And these are deployed at 1 kilometer intervals, and we hope to capture some of that southern migration of fish if they're hugging the coastline there as they move south. In addition to our static array, we also have an autonomous liquid robotics wave glider, which is outfitted with a VR2C receiver and solar panels. So it's capable of sort of long-term deployments where it can listen for fish and take water profile measurements. And we typically do these sort of pre-planned sort of zigzag routes searching for fish, and then a more concentrated search pattern when a fish is detected. So far we've downloaded 18 of our 21 inlet receivers. We haven't downloaded the offshore array yet. Unfortunately, we've lost 2 of our receivers, one at Drum and one at Bogue Inlet. And we've had 1 receiver wash up at Ocracoke Island that we have not been able to recover yet. But from our receivers and the other receivers in the area, we've detected exactly half of our tagged fish so far. On the inshore array, we've detected 47 southern flounder as well as 36 unidentified species. The wave gliders detected 4 southern flounder and 10 other species, and recreational anglers have reported the capture of 4 of our fish. If we look at what fish that were tagged in the Albemarle are doing, we've detected 18 of the 35 fish tagged here. 12 were detected on DMF receivers at Mans Harbor Bridge. Only 1 fish was detected at the nearest inlet, which is Oregon Inlet. Our receivers, ECU receivers, are shown in yellow, whereas other receivers in the area are shown in white. Interestingly, we also had an individual detected to the west of the tagging location at the Alligator River Bridge. And this is kind of cool because we do have some anecdotal evidence from fishermen that they say that fish kind of move south and west to Alligator River and out through this canal, kind of shown here at the bottom. So this could be evidence of some of that movement. If we look a little bit farther afield, we had 5 fish detected at Hatteras Inlet and 1 fish at Ocracoke that were tagged from the Albemarle. 3 of these individuals were first detected at Mans Harbor Bridge before being detected at those inlets about a month apart. We also had a fish that must have traveled at least 3 kilometers per day and was detected at Drum Inlet. So it's possible that it kind of went the sound route past Mans Harbor and then bypassed those 3 inlets to the north before exiting through Drum Inlet, or that it possibly went the back route through Alligator River Canal. And then, which would make sense because Drum Inlet and Ocracoke Inlet are probably the closest exit strategies if it went that back way. So clearly we're already seeing a lot of individual variation in the routes that these fish are taking and the timing of their egress. If we look at what fish in the Pamlico Sound are doing, it's similar, distribution of fish across numerous inlets. We also had all 4 of our fish that were caught by recreational anglers from here in Evergreen Slough, which is just south of Ocracoke. This is not a slough where we currently have receivers, but we are planning to put out receivers in this area in the near future to capture any of that movement of fish sneaking through this new slough that kind of opened up this year. So fish that were tagged in Core Sound was a little bit more simple because all 22 of the 37 fish were detected in Barden's Inlet. And what's really cool here, which you can't really tell from the other inlets based on the configuration of the receivers, is that we can really see the direction of movement as these fish are detected on different receivers in the area. So this individual is pretty typical of what we're seeing, where the fish was tagged in late November. It was detected on these UNC Wilmington receivers shown in white for several days. And then all of a sudden on December 2nd, it kind of got the urge to go and left the inlet within an hour and a half. However, we're also seeing evidence that some fish may not be making these offshore migrations. They may not be leaving the inlets. We had several individuals, but this one is pretty typical. It was first detected on December 1st and then detected pretty consistently in the array through February. So it's possible that this fish and other fish like it may just not be ready to make the migration, the spawning migration. They may just be going through the motions, not ready to leave. And that we may see this fish leaving in the next year or so. So to answer our first objective, well, we're finding that it's a lot more complicated than we thought. There's a lot of individual variation in both the routes that these fish are taking to leave the sounds and the timing. Previously, it was thought that the fish would be leaving between September into November, but the majority of our fish are being detected in the inlets in early mid-December. More data is needed to see whether this is a consistent pattern or whether it's just interannual variation. It's also possible that the migration was delayed due to post-release stress in the whole tagging procedure, or that because we tagged late in the season, these are just fish that are naturally a little bit slower than the rest of the population in making these spawning migrations. So clearly more data is needed. This is still very early in the project. It's currently a 2-year project, so we're working on some more funding to extend as well. But I want to move on to our second objective, which is to track the offshore spawning migration and to identify some potential spawning habitats. So our wave glider has detected 3 individuals that were first tagged in the Albemarle. All 3 of these individuals were first detected at Mans Harbor Bridge. 2 of them somehow snuck out an inlet and were then detected offshore. But this third individual, where you can see in the middle, which is ID 54578, was detected at Mans Harbor on November 5th, at Ocracoke on November 29th, and then a week, 10 days later, offshore, and it was actually detected twice by the wave glider offshore in 2 different locations. So this is really cool. This is exactly what we want to see, where we can really monitor every step of the process or of the migration route as this fish, leaves the sounds out an inlet and then detected offshore. What's interesting about these 3 individuals is that they all seem to be making a southerly migration, and they all are within this sort of 15 to 20 kilometer band of the coast. So it's possible that these fish are using, a depth gradient as they're moving south. The wave glider also detected a fish that was tagged in Core Sound. It was tagged on November 20th. It was detected in Barden's Inlet. And then it was detected way offshore at the edge of the shelf here on January 29th. And this is really exciting because it supports some Division of Marine Fisheries satellite tagging of southern flounder, where they've also been seeing some of these cross-shelf movements. And this is where we have hypothesized that southern flounder may be spawning out here on the edge of the shelf. So this could be early evidence of that. So in addition to the telemetry work that we're doing, we're also doing some hydrodynamic modeling to estimate spawning location. We're using larval flounder that will be doing some otolith aging that were collected via ichthyoplankton sampling in Beaufort, as well as some ichthyoplankton sampling from offshore transects. In the next coming year, we'll also be putting out another 100 tagged southern flounder. We'll be doing 2 wave glider offshore missions in December and January, and we will continue to be maintaining our inshore and offshore arrays and collecting that data to hopefully do some more individual-based modeling as well as some more population-based network analysis. And I'm excited about the workshops over the next 2 days to maybe pick up some new analysis that could be useful for this project. So I'd like to acknowledge the Southern Flounder team, all of our collaborators at other institutions, the commercial fishermen who have been very helpful in helping us get fish to tag, our funding source, and then the MATOS organization for putting on this great meeting. And so I believe I have a few minutes for questions, which I'd be happy to answer, or you can always email me. Thank you.
Thanks, Caitlin.